I'm really excited to go over with you one of my favorite examples in all of Python, how to determine if a two-digit number is prime using simple elif statements. So go ahead and open up a new collab notebook and title it appropriately. And start to think about how we might write this function. If we're going to determine if it's prime or not, we want the output to be a Boolean, so a true or false. Right? So def is prime. It's going to be a true or false. And then our input for the function, which is our parameter, is going to be a number. Now, a nice way to approach this problem is to think about how you would do it if it was an even number, right? Like 50 is not prime because it's even. So how would we go about just that part of it? Like let's say it is odd. Okay, well we would need to sort of determine if it's even, and we need to do some type of an operator on number. Think about for a moment, what is the operator that will do this? How can you use Python to determine if a number is even? Well, it's actually the modulo operator. So num mod 2 will be 0 if it's even and 1 if it's odd. So to check if it's even, we want to check if it's equivalent to 0. Okay, and if this condition is met, and it is a true or false due to this equivalence operator, then we know it's not prime because it's even, so we can go ahead and return false and close the function. Now, if we reduce this just to the is odd, we can also go ahead and otherwise, in all other cases, it will be odd and we can return true. And so this is the general structure that the function is going to take. So let's go ahead and run and store this subcode, which determines if it's odd. We'll keep it titled is prime so that we don't have to change it later. So is prime, and if I want to check number 14, well, false, right, because it's even, whereas if we choose the number 15, in this case we get true. Now it's not the case that 15 is prime, but we've only checked even numbers, and it is the case that it is in fact odd. So what we need are more checks like this one, okay? And again, you want to start to think about, okay, what's the code that you could write next, right? The next number to typically check would be 3. Can you write code that will sort of discount 15 because it's divisible by 3? Well, after an if statement, if you have more than one case, we already have an else, you need an elif statement. And you do the same type of a check. So it'll be num mod 3 equivalent to 0. In this case, we want to go ahead and return false again. And the pattern continues, okay? We want to do this for all the prime numbers only. So we check 5, is it divisible by 5, like 25? This will discount 25. We don't have to check 4 because 4 is divisible by 2. So we only have to check primes because all numbers can be uniquely decomposed into their primes multiplied by each other. And the big question then is, when do we get to stop? How high do we have to check? Okay? And it may surprise you to find out that you can actually stop here. Okay, why is that? We've only checked 2, 3, 5, and 7. Okay, the next prime is 11. 11 times 11 is 121. So that's a 3-digit number. That means if 11 as a prime number, say divided into some 2-digit number, it would have to be multiplied by a prime number that is less than 11. Like 99, 3 goes into it because it's 11 times 9, etc. And so because all prime numbers larger than that fit that same criteria, you can actually stop here. In effect, you can check less than or equal to the square root of the number that you're checking, which in our case would be 100, and the first prime less than 10 is 7. Okay, so this should work. Go ahead and press Shift Enter. Notice that it's only working for 2-digit numbers. Okay, now we can check 15 again. We get the expected false. 25, false. Let's try 77, false. How about 91? Now that's false. 7 goes into that because 7 times 10 is 70. And then 21's left over and 7 goes into 21. What about 93? False because 9 plus 3 is 12. 3 goes into it. How about 97? I'm trying to check ones that you might be unsure about. 97 is true. 7 is not a two-digit number, but 17 is true. 89 is true. Well, it should be true. And it appears that our function works.